Okay, so for the first one here, 4 milliliters of serum is added to 12 milliliters of saline. What is the dilution created? Remember, the first number in our dilution is the amount of serum. The second number is the amount of total solution. So our second number here is not the 12, it's going to be 16. Well, plus 4 milliliters. So the milliliters cross off, that's 4 and 16. Or reducing that fraction 1 to 4. So that is a 1 in 4 solution. Number 2, 30% dextrose solution is diluted 1 in 5. Find the new concentration. Remember, we said these dilutions are proportional to the concentration of the solution. So it's a 1 in 5 dilution. 30% is the concentrated percent. It's the higher percent. We're diluting it. We're expecting the percent to get smaller. So the 30% goes with the 5. We can cross, multiply, and divide. 1 times 30 is 30. Divided by 5 gives us 6%. So that diluted solution after the 1 in 5 dilution is 6%. Now, another way you could have approached that is you could have taken the 30% times the 1 in 5 dilution written as the fraction 1/5. That would give you 6%. Any questions on the first couple? Number 3, find the new concentration if 120 milliliters of saline is added to 80 milliliters of 45% solution. This is our change of concentration formula, or sometimes called the concentration adjustment formula. C1V1 equals C2V2. Now, the concentration can be converted to a decimal or it can be left as a percent. I'm used to converting it to a decimal. So we're starting out, probably the hard part here is picking out of the problem what our initial concentration and volume is. We have 45%, 0.45, times a volume of 80 milliliters. That's going to equal our new concentration, which is what we're going to try to find, C2 times. Now, once again, that volume, we had 80 milliliters, and we added 120 milliliters to it. So that gives us, that is 0.45 times 80 is 3.6, 36. Equals C2 times 80 plus 120 is 200. And we divide that out, solving our equation. Kind of running out of space here, but divide by the 200. 36 divided by 200 is 0.18. Is our new concentration. So we have to convert that 0.18 to a percent, 18%. Any questions there? Number 4, how much serum is required to create 80 milliliters of a 15% weight and volume solution? So here's our key right here, 15% weight and volume. So 15% means there's a ratio of 15 out of 100. The weight and volume is significant because that tells us what units are going to be over on the other side of this. Weight and volume means that the weight, technically it should be mass and volume, is measured in grams, and the volume is measured in milliliters. A weight and volume solution, that's always the standard. We're comparing grams to milliliters. So we do have 80 milliliters we need to find how many grams. 15 times 80 divided by 100. It's 12 grams. So it requires 12 grams of serum to create the 80 milliliters of a 15% weight and volume solution. Any questions there? Now, on the more practical side of this, I wrote these questions that way to test the math. But on the more practical side of this, most of the time, if we're doing a dilution to change the percent of a solution, we're not going to add a certain amount of saline to it. We're going to be shooting for a particular percent. So we might have 60 milliliters of a 15% solution. And we might need, well, let's say we need 10% solution. We need to know how much saline to add to dilute that down. So that the tough part of these is figuring out what concept, what formula is being used here. We are changing the concentration. There are two ways to look at that. I didn't ask for dilution, I asked for the amount, the volume. So we have 60 milliliters of 15%. Most likely looking at our change in concentration formula here. C1V1 equals C2V2. So we put that in, 60 milliliters. 0.15 is our concentration times 60 milliliters. Equals our new concentration is going to be 0.10. We want it to become 10%, and we're looking for that new volume. 0.15 times 60 is 9. To solve for the volume, then, we're going to divide by the 0.10. Giving us 90 is our new volume. Our volume before was milliliters, so this is still in milliliters. 90 milliliters is our new volume. We were asked how much saline to add. So we have to subtract from that new volume we have to subtract the 60 milliliters that we already had. So we call that the old volume or original volume. Tell us that there's 30 milliliters of added saline. So that one used our change of concentration formula because it asked us what volume of saline to add or what volume we needed that final solution to be. Similar to that, we could be asked, without any volumes involved, might be asked what dilution is required to dilute 36% solution to 8%. Do this, remember the ratio of our dilution. Let's concentrate total is equal to old concentration, the old percent, which is the 36% on bottom, or new concentration, new percent on top, the 8%. So to find the actual dilution here, we're just going to take that 8 over 36, the percent symbols will cancel out, and we're going to reduce those fractions. Both 8 and 36 can be divided by 4. 8 divided by 4 is 2. 36 divided by 4 is 9. That is a 2 in 9 dilution. So again, the difference between that question and the previous one, this previous one I was asking you for a volume of saline or a total volume of solution. This one, I was just asking you what dilution to use, and I didn't give you any of the volumes involved. We did problems similar to this a couple weeks ago, and we did one or two last week. Let's say a blood glucose meter has a limit 900 milligrams per deciliter. Anything that registers over that will register an error on the meter. So a sample being tested results in an error. So as we look at this, we're going to have to dilute the sample. So we're going to be asked to perform a 1 in 4 dilution with 200 microliters of blood and retest. So let's do that part first. We're asked to perform a 1 in 4 dilution. 1 in 4 dilution is 1 over 4. Remember, 1 is the serum. In this case, that's the blood. And the 4 is the total solution. On the other side of that, we know we have 200 microliters of blood. Cross, multiply, and divide. 4 times 200 divided by 1. 800 microliters. But remember, that is solution. So to perform that dilution, what we need to do, we need 800 microliters total solution. We're using 200 microliters of blood. That means we are going to be adding 800 minus 200 gives us 600 microliters of saline. So that performs that 1 in 4 dilution. So after we dilute the sample, we retest. The meter reads 264 milligrams per deciliter. Find the true level. So we have that 1 in 4 dilution that we did. That's going to be important. Now, what we tested here, the 264 milligrams per deciliter reading, That was a diluted sample. So that means all the levels are smaller than what the real levels are. So we would expect the true level to be larger than that. So the 264 goes with the smaller number in our 1 grams per deciliter. And we're going to cross multiply and divide to get the true level. 4 times 264 divided by 1 is 1,056 grams per deciliter. So that is their true blood glucose level. So questions come up. First of all, how do I know what dilution to perform here? Well, in anything we do, you're going to be given what the dilution is that you're going to perform. You're either going to be given the dilution that you're going to perform, or you're going to give the amount of saline that you add. But if I'm looking at this, and I ask you what dilution would you perform, some people might say, well, I'm just going to add a whole bunch of saline to make sure that the reading is down below and it's within the levels of the meter, which that's part of what we're doing is we're diluting it to get into that level. But what happens if we over dilute it? Brings into the effects of dilution on meter tolerances. Let's say that meter is accurate to plus or minus 2%. What that means is plus or minus 2% of an actual level. So the actual level on this last reading was 1,056 milligrams per deciliter. 2% of that, I'm just going to take a shortcut, multiply by 0.02. .12 milligrams per deciliter. That means that reading could be off by up to 21.12 milligrams per deciliter. The reading given on the meter was 264 milligrams per deciliter. This error still applies. So the effective error here, if we compare that 21.12 milligrams per deciliter to the 264 milligrams per deciliter, we cross multiply and divide here, that's now 8 out of 100, or 8% error. When you perform a dilution like this and you test the diluted sample, the error of the meter, the tolerance of the meter, is magnified by the same ratio as the dilution. This was a 1 in 4 dilution. The error of 2% was magnified from 2% to 8%. So when we talked last week about the syringes, how you want to syringe, the more full the syringe is, the less error there is, because whatever little distance you're off in the position of that plunger, it's going to be less volume of medication, the narrower your syringe is. Same type of thing here. When you're performing a dilution, in order to dilute a sample so it's within the capabilities of the meter, you want to dilute it as little as possible to still bring it into the meter's range. So doing a 1 in 4 dilution here was probably more dilution than we needed to bring it down. We brought it down to 264. We only needed to bring it down under 100. Okay, enough about dilutions. We beat those to death. Anybody have any questions on the dilutions or change of concentrations and stuff like that? Okay, so what we're going to move on to today, we're going to spend a couple weeks here on the actual dosage calculations. There are three main methods that we can use for calculating dosages. I have struggled for years on how to teach this. There's a part of me that just wants to teach you my way because I think it's so much easier. But I've kind of settled on at least showing you the other methods. When you do your dosage calculation tests throughout your program, they don't spend a lot of time teaching it. A lot of it is, here's your textbooks and manuals, figure it out and take these tests. It's a little better than it used to be. They do spend some time in your classes figuring it out. But a lot of the textbooks want to give you a formula and say, in this situation, you use this formula and you go ahead and do it. I don't like that because there's 3 or 4 different formulas then that you have to memorize and know when to apply. Dosage calculation formula is the one I'm going to show you first, and then we'll work up to the one that I like best. I'll let you guys decide which one you like best as you're doing the homework. So the first method we're going to show you is dosage calculation formula. So the dosage calculation formula is E over H times V equals A. So let's define some vocabulary here. D, the doctor's ordered dose. H is what is referred to as the on-hand dosage. Now, the on-hand dosage and V go together. V is the vehicle. Vehicle is what carries the on-hand dose into the patient. So it's really hard to define the on-hand dose without knowing what the vehicle is. For example, if it's tablets, the tablet is the vehicle. The on-hand dosage is how much medication is in each tablet. A is what is administered to the patient. Let's do a couple of examples here. Let's say the doctor orders 700 milligrams of medication. Supply is 200 milligrams or tablets. Scored just means they're marked, so they're easy to break in half. For this class, we're going to assume that any tablets can only be broken in half. So tablets must be rounded to the nearest half tablet. Different medications might have different standards, but for the most part, as far as I'm aware, most tablets can only really be cut in half accurately. These smaller units than that, they kind of discourage. So anyway, let's calculate what needs to be administered to the patient here. So D is the doctor's ordered dose at 700 milligrams. Now, one hint to help us find the on-hand dosage. Their on-hand dosage must have the same units as the doctor's order. Same units. So the doctor's order is in milligram, the on-hand dose has to be in milligrams. And it is, it's 200 milligrams. 200 milligrams scored tablets, that's giving us both the on-hand dose and the vehicle. 200 milligrams is the on-hand dose. The vehicle is one tablet. 200 milligrams per one tablet. So the milligrams cancel out. If you calculate this, it'll be 700 divided by 200 times one tablet. 3.5 tablets. If you left it like that, that's okay. This is okay with me, but a lot of times I prefer you to write it as 3 1/2. Question? No problem. Any questions on that first example? So you notice we're starting with what the doctor orders and we are working through to get what is administered. Another example using that formula, let's say the doctor orders 40 milligrams of a medication. Our supply says that it is constituted at 25 milligrams in here, 4 milliliters. Yes. 25 milligrams and 4 milliliters?
Really? They want, what do they want?
The doctor wants you to give 40 milligrams of medication to them. You're looking, basically the supply, this comes off the bottle label.
Oh, okay.
It's telling you that the medication in that bottle, there's 25 milligrams of medication for every 4 milliliters of fluid. So our doctor's order is 40 milligrams. The label on the bottle or the supply gives us the on-hand dosage and the vehicle. So the 25 milligrams has to be the on-hand dosage, has to have the same units as the doctor's order. Times the vehicle, 4 milliliters. Because 4 milliliters is what carries that 25 milligrams into the patient. So what cancels out here? The milligrams cancel out. The unit on our administered dose is always going to be the unit of the vehicle. Notice this is milliliters. Our administered dose will be in milliliters. Up here, the on-hand was in tablets. Our administered dose was in tablets. So you would do 40 divided by 25 times 4, which is what, 6.4? 6.4 milliliters is administered to that patient. Questions? Richmond, I think you're muted, so I can't hear you if you're trying to ask something.
We're just talking to ourselves.
Okay, sorry, I just wanted to make sure. Okay, so that's the dosage calculation formula. The next option for calculating is a proportion. proportion kind of works backwards a little bit, in my opinion. What we're doing with a proportion is we are looking at the vehicle and the on-hand dose again. The on-hand dose compared to our vehicle. The other side of that proportion is the doctor's orders compared to what we're going to administer. So the part we're looking for is generally that part right there, the amount that's going to be administered. So we're going to do the same two examples again. 700 milligrams is what our doctor has ordered for the patient. As we look at the label on our bottle, the supply says 200 milligram tablets. So if we look, our supply is what gives us the on-hand dose and the vehicle. That is saying 200 milligrams per one tablet. The other side of this equation, the doctor's order, is the 700 milligrams. In this proportion, it is important to know that whatever units are on top on one side have to be on top on the other side. We have to match those up. Whatever units are on bottom on one side, we have to have the same units on bottom on the other side. So on the other side of this is going to have to be tablets. And just like with any proportion, we cross multiply and divide. So 1 times 700, one tablet, I should say, times 700 milligrams is 700. Divided by 200 is 3.5 tablets. Technically, the units here when we cross multiply would be 700 milligrams times tablets. You divide by the 200 milligrams. Milligrams divide out, and we're left with tablets as our unit. Our second example is an order of 40 milligrams of medication. The label on our bottle told us the supply was 25 milligrams in 4 milliliters. So our supply again gives us the on-hand dose in the vehicle, 25 milligrams, 4 milliliters. So we know right now that on the other side, this has to be milligrams, this is going to have to be milliliters. Doctor's order was for 40 milligrams. It's here. And once again, we will cross multiply and divide. 4 times 40, 160, divided by 25 is 6.4 milliliters. We had the same result we did before, just a little bit different way of setting it up. Now, at this point, we've looked at two methods. I prefer the proportion over the dosage calculation formula because the proportion isn't anything to memorize. You just have to match things up, cross, multiply, and divide. If I did things backwards here, when I set up this first ratio, what if I said 4 milliliters, bless you, to 25 milligrams? Bottle wasn't it?
Last week it was.
So if we did 4 milliliters to 25 milligrams, it doesn't matter because we know on the other side of this, the units have to match up. So the doctor's order of 40 milligrams is going to still have to go on with the milligrams. So all that changes is the number we're going to calculate is on top instead of on bottom. So there really is, it's very difficult to screw up the proportion method. Because even if you do flip one ratio, the other ratio just flips to match it. As long as you keep the units matched up, you'll still get the correct answer. Now with that said, both the formula and the proportion have one weakness. That is, they can only go one step at a time. In other words, if there are multiple steps that have to be converted, you have to apply the formula multiple times or apply the proportion multiple times. Whereas our third method that we're about to look at can do all of those in one single process. So what we're looking at is dimensional analysis. Dimensional analysis is actually an extremely powerful process in math. And what it is exactly what it sounds like. It's using the dimensions to figure out what the calculation needs to be. Anytime there is a rate, one of the key tenets to dimensional analysis is that any rate can become a conversion factor. Now, in the last unit, when we were doing our unit conversions, converting from pounds to kilograms or from grains to milliliters, whatever, we were using conversion factors. That was dimensional analysis. The next step of dimensional analysis and application is to use rates as conversion factors. For example, let's say that we have something that is traveling at a speed of 60 miles per hour. 60 miles per hour is a rate, but it's also a conversion factor. It is saying for that object, 60 miles is equivalent to 1 hour. Or the other way around, 1 hour is equivalent to 60 miles. And we can use that conversion factor. If we're asked, how long would it take to travel 420 miles? There are all sorts of formulas out there for how do you calculate time if you're given the distance and the speed. I hate formulas. I shouldn't say I hate formulas. Formulas are good if you can remember them. I don't like memorizing a bunch of stuff that applies to only certain circumstances. I like memorizing processes that can be applied to a lot of different circumstances. Dimensional analysis takes over here. How long would it take to travel 420 miles? Well, I'm starting out with 420 miles. I put it over 1, make it a fraction, just like I did when we were converting our measurements. The conversion factor I'm going to use, I want to go from miles into time, it's going to be hours. That conversion factor comes from my rate. That's telling me 60 miles is equivalent to 1 hour. Miles cancel out. 420 times 1 hour is 420 hours over 1 times 60 is 60. 420 hours divided by 60 is 7 hours. I didn't need to memorize a formula. I used the units to tell me what calculations had been done. The same happens when we're using dimensional analysis for our dosage calculations. For our dosage calculations, we start, just like here, we started with the given information, which was how far we needed to travel. and we convert it to our answer. So for dosages, what we're given is the doctor's orders. And we're going to convert that into what needs to be administered to the patient. So let's go through our two examples again. So our first example was an order for 700 milligrams. The supply on the bottle said 200 milligram tablets. So we start with the order, start with the given information. 700 milligrams. Make it a fraction by putting it over 1. The supply here becomes a conversion factor. That 200 milligram tablets is telling us 200 milligrams is equivalent to 1 tablet. So we have milligrams right now. We want to get rid of those. Milligrams are on top. We put them on bottom so they cancel. Our equivalency here, it's 200 milligrams equal to 1 tablet. So the 1 tablet has to go on top. And notice the milligrams cancel out. 700 times 1 tablet is 700 tablets. Over 1 times 200 is 200. 700 tablets divided by 200 is 3.5 tablets. So what I like about this is similar to the proportion, there's nothing to memorize. You just start out with what you're given and work towards where you need to go. As we're going to see after a couple of examples, the strength here is that we can go through multiple levels of conversion without having to start over and reapply. Let's do our second example. Our order, 40 milligrams of medication. Apply, 25 milligrams, 4 milliliters. Now again, we're going to start out with our order. The supply here, the 25 milligrams and 4 milliliters, is again giving us an equivalency. It's saying 25 milligrams is equivalent to 4 milliliters. We're going to use that as a conversion factor. So we start out with the doctor's order, 400 milligrams. We put that over 1 to make it a fraction. So in our conversion factor, we're getting rid of milligrams, so we have to put milligrams on bottom. What we have here for an equivalency for milligrams, the anything else is the 25 milligrams, the 4 milliliters. Milligrams cancel out. 40 times 4 milliliters, 160 milliliters. 1 times 25 is 25. 160 milliliters divided by 25, 6.4 mil. That's it. It is.
Look at all this.
Units just kind of make everything fall into place for us. Now, like I said, the strength of this is that when we run into conversions that need multiple steps, dimensional analysis can handle it all at once. Let's take a look at an example of what I mean here. So let's say our order is for 1,200,000 units. our supply. So the label on our bottle tells us this is 100,000 units per milligram. And 5 milligrams per milligram. We're using the dosage calculation formula here. What we need to administer to the patient is going to be milliliters. This is a liquid medication. So we're going to administer it to the patient in milliliters. We're going to use dosage calculation formula. Fall short a little bit. We start with 1,200,000 units. Now remember, the on-hand dose that goes underneath the doctor's order has to have the same unit. So the units here is units. So it's the 100,000 units. Has to be our on-hand dose. Well, the vehicle that goes with the 100,000 units, 100,000 units per milligram. That's 1 milligram is that vehicle. So the units cancel out. 1,200,000 divided by 100,000 times 1 milligram. That's 12 milligrams that needs to be administered to our patient. But we're going to administer it to the patient in milliliters. So we have to apply this formula again to get from milligrams to milliliters. So right now we've converted the doctor's orders from 1,200,000 units to 12 milligrams. We still have to convert that into a dose that we're able to administer to the patient. So from the 12 milligrams, we have an on-hand dose has to be in milligrams. That must be the 5 milligrams. The vehicle that goes with that 5 milligrams is the 4 milliliters. Scroll up a little bit here. Now the milligrams cancel out. 12 divided by 5 times 4 milliliters, 9.6 milliliters. So that's what has to be administered to the patient. I mean, it's not painful, but it's a little tedious to have to apply the formula a second time. And we would have the same experience with the proportion. We're going to do the same problem with the proportion. Did it work? So once again, we're ordered 1,200,000 units. And our supply label on the bottle tells us 100,000 units per milligram and 5 milligrams per 4 milliliters. So remember, portion on hand over the vehicle equals the doctor's orders over what's administered. Problem here is we have two pairs of on hand and vehicles. We have the 1,000 or 100,000 units per milligram, and we have the 5 milligrams per 4 milliliters. Figure out which one we want to use first. We look at the doctor's orders. order is in units, so we need to start out with whichever one of those fits in it. It's going to be the 100,000 units per milligrams. That's per 1 milligram. The other side of that, 1,200,000 units ordered by the doctor goes on top because we have to have units on top. And we'll cross multiply and divide. 1,120,000 units times 1 milligram divided by 100,000 units is this 12 milligrams. We're going to set up this proportion a second time using our second on-hand dose equal to 5 milligrams, 4 milliliters. On the other side of that, we're going to use this result here, the 12 milligrams is going to go in as our ordered dose. And once again, we'll cross multiply and divide. 4 times 12 milligrams is 48, divided by 5, 9.6 milliliters. Getting the same result. Once again, we had to apply the process twice. Now, I showed you both of those in hopes that you'll never do them that way. My preferred way, again, if you like one of those two methods better, please feel free to use it. My preferred way of doing it, I'm never going to mark it wrong if you don't do it my way. The way that makes the most sense to you is the way you should do it. But for me, dimensional analysis, and part of it is because I've done dimensional analysis in so many other settings that it's natural to me. But once you get used to it, it is just so much simpler and more fluid to use. And it's the same process, same formula. So once again, let's look at that order. I just realized I went way past our break. We'll finish this problem and we'll take our break. Time flies when you're having fun. So our supply, the label says 100,000 units per milligram and 5 milligrams per 4 milliliters. Again, these two on-hand dose and vehicles give us conversion factors. This first one is telling us that 100,000 units is equivalent to 1 milligram. The second one is telling me that 5 milligrams is equivalent to 4 milliliters. So I'm going to start out with the given information, which is my doctor's order. $1,200,000 units, and I put it over 1. Well, I want to get rid of units. I'm going to put units on bottom here. So I look for a conversion factor involving units. I have one right here, 100,000 units, equivalent to 1 milligram. So I'm going to cross off the units. I have canceled them out. I've eliminated the unit of units. Now everything is in milligrams. I want to get rid of milligrams. So I'll put it on bottom so those will cancel out. I look for an equivalency with milligrams. 5 milligrams equals 4 milliliters. That it. Notice now the milligrams will cancel out. And now I just multiply. So 1,200,000 times 1 times 4 milliliters is 4,800,000 milliliters. On bottom, 1 times 100,000 times 5 is 500,000. And we divide that out. 9.6 milliliters. To me, that's a lot quicker and easier because everything is just set up linearly, one right after the other like that. Now, to be fair, in practice, I prefer to eliminate zeros. Be very careful as you eliminate zeros. You can eliminate 1 0 from the top of any fraction, along with 1 0 from the bottom of any fraction. So I can eliminate 1, 2, 3, 1, 2, 3. I could keep going if I wanted to and eliminate 2 more each. That would just turn that into 48 over 5. It divides out easier. Unless you're very confident in doing that, be very careful. It's not that hard to punch zeros into your calculator as you're doing the calculation. Okay, I've gone 11 minutes past our break. It's 11:31. Let's go ahead and take a break and we'll come back at 11:40 and start back up. Sorry about that. I let time get away from me. They're really bad.
I'll tell you what the drug is. But like when you go to like look at the word problem, it'll tell you what drug.
But that's freaking head roadblock.
It really is.
I would never. I literally,
Because I saw like, I saw.
there.
Dave never.
I go into Atlanta like.
Oh, no.
We go 3 hours and never stop.
He always forgets. Don't forget to remind me.
How can you talk that long? He never stops.
That's why we just get up and walk out like, all right.
Oh, yeah, we gotta go to
Back
that.
home.
Don't fill our water bottle.
Mhm.
I didn't make it through all of them. Did you finish?
So excited.
That's outside our.
Yes, I absolutely do not. Solution 13.
You print off your solution, this page is set out in Untitled. Because it takes you step by step. 13
I didn't even know that.
on which section.
And then I know it lasts all the way up. Well, sometimes I got to in the morning, but like.
Yeah.
I would get.
It's that secret. Totally. I'll post the solutions to it.
Oh, because I'll look at my class.
Because then
I would have class from Washington. I would 6 to 10. I absolutely hated it. I hated it. And sometimes I did have to. I was like, okay,
and then do this, and then
it doesn't make sense. And like, no, yeah, no, I literally.
I said I need my page, I just.
Or,
There's one. Yes, that's the one that I didn't show her.
Exactly.
We're usually really good at
Yeah.
this, but I could get it. No, she's,
Okay, that's fine.
so she like sent me this long explanation,
So,
step by step of how
I
to do it.
also have this.
Yeah.
That's why, yeah.
This way.
I don't go along. Time I went there and I spent over.
And like some, you can do some of it for free, but
Yeah.
there's some,
I gotta go over it.
yeah. And I
Everything.
I paid for it.
They literally, I'll be like, and I think it's cheap. And then like, I think it's cheap and all that shit, but then all of it. It's like $4 for this thing, $4 for this thing, $4 for this thing. Yeah, it's been a problem. I'm not afraid to leave it. Okay, that's not bad.
This old stuff I have.
Oh, yeah. It's I'm scared. I gotta go get new tires. You don't have to do one. Your daddy has it? I see him driving around all the time, and like, I always think I'm like, this one. Yeah. Yeah. He comes in, he would you. Yeah, if he came out, I was like, I think of it.
Well, yeah, he's trying to win this.
Yeah, I tried looking at the answer. I just stopped there, it was like,
Tall, you know, like his head was just like me, not like his head
It helps you with visual models. Gives you stuff.
usually the ones that like I have an example that I can give for us. It's the wording, like if it's not worded, it's kind of the same. It was a word.
So just.
I think that's.
Did you do it? I don't know what he's done, what kind of weight he's got.
Okay, it's 11:40 as we're getting everybody gathered back in here. I'm gonna put a couple up here for you guys to try in your notes, see what you can do with them. We'll go over them in just a minute. Some of you might not be totally finished here, but let's take a look and see how you're doing. So our doctor's order for the first one is 20 milligrams. 20 milligrams over 1. And again, we use the supply as an equivalency, a conversion factor. We have to get rid of milligrams, so we'll put milligrams on the bottom. And that supply is telling me that 50 milligrams is equivalent to 3 milliliters. Milligrams cancel out. 20 times 3 milliliters is 60 milliliters. On bottom, 1 times 50 is 50. 60 milliliters divided by 50 is 1.2 milliliters. You'd administer 1.2 milliliters of medication to our patient. Any questions on that one? Okay, so for the second one, we start out with the 1,000 milligram order. Put it over 1. Our supply, we got milligrams need to go on bottom so they cancel out. Our supply tells us that 300 milligrams is equivalent to 1 tablet. So the milligrams cancel out. 1,000 times 1 tablet is 1,000 tablets. 1 times 300 is 300. We divide that out. 3 1/3 tablets. Now for right now, if you got to that point, I'm okay with that. But we had mentioned tablets need to be to the nearest half tablet. So our next level, our next step, would be to round this to the nearest half a tablet. Sometimes it's easier to round if we think of the number line. This is 3 tablets, 3 1/2, 4 tablets. 3 1/3 is going to be here between 3 and 3 1/2. Which one is it closer to? 3 1/3 is somewhere in here that's closer to 3 1/2. So we would administer 3 1/2 tablets. Any questions? Let's step it up a little bit. So let's say our doctor orders 0.125 milligrams Synthroid PO daily. All of you go through the abbreviation so you can tell me what that means. By mouth, PO, orally. The supply bottle of 100 word tablets. $50 micrograms per tablet. So I'm giving a little bit more information here to help you see what would be more likely to be the way the label is written out and pick out the information. Do we care how many tablets are in the bottle? No. So this 100 scored tablets doesn't mean anything to us. What we care about is that 50 micrograms equals 1 tablet. That's our equivalency here. We start out with the doctor's order. .125 milligrams. Put it over 1. As we go to convert this, we need to get rid of milligrams. We have to have milligrams on bottom here. Problem is, we look at our equivalencies and we don't have an equivalency with milligrams in it. We have an equivalency with micrograms. Now, those are both units of mass, which means we know how to convert between them. So we have to get this from milligrams to micrograms using our knowledge of conversions. I'll put micrograms on top. What is bigger, a milligram or a microgram? Milligram. If we look at our conversion chart, we've got grams, decigrams, centigrams, milligrams. Then 3 notches down, we have micrograms. So micrograms are smaller. In fact, 1 milligram contains how many micrograms? Magic number is usually 1,000. 1,000 milligrams in a gram, 1,000 micrograms in a milligram. So that has converted our milligrams to micrograms. Now that's in a unit that we can use with our equivalency here, our supply. Here are the micrograms, I put them on bottom. That tells us that 50 micrograms is 1 tablet. Now the micrograms will cancel out for us, and we'll multiply this out. 0.125 times 1,000 times 1 tablet is 125 tablets. On bottom, 1 times 1 times 50 is 50. 125 divided by 50 is 2.5 tablets. Or 2.5 tablets.
So what is it asking?
What's to administer to the patients? How would you administer that?
So this, we're just talking about,
Single
take
dose.
this time.
Next week or the week after, we'll look at safe dose, and then we'll start to consider basically you're double checking the doctor's recommendation, the doctor's order at that point. So then you have to double check if the recommendation is so much every 8 hours, and the doctor's recommending the dosage every 6 hours. How do you compare those? But for right now, we're just looking at the safe dose. So let's say we have an order. Codeine, DRSS, PO, U4H. What does that mean? PO is orally. U4H is every 4 hours. I'm not going to keep quizzing you. Our supply. We have both 15 milligrams tablets, and we have 60 milligram tablets available to us. So I'm going to start out with the doctor's order. GRSS. What does that mean? SS means 1/2. GR is grain. Got to start out getting rid of grain. Now we don't know where to go with it, so let's look at our on-hand dosage. Those are in milligrams. We're going to take grains to milligrams. What is our relationship between grains and milligrams? Remember? One grain is 60 milligrams, approximately. So the grains Cancel out, we're now in milligrams. Now we're left with kind of a decision here. We have 15 milligrams and 60 milligram tablets. We don't know which one to use next. So at this point, we're going to do it both ways and see which way it works out. Let's start out with the 15 milligram tablets. So milligrams go on bottom, so it cancels out. 15 milligrams in one tablet. Milligrams cancel out. Let's calculate that through. 1/2 times 60 times one tablet is 30 tablets. On bottom, 1 times 1 times 15 is 15. 30 tablets divided by 15 is 2 tablets. That doesn't seem too bad. If we redid this calculation for the 60 milligram tablets, our first several steps stay exactly the same. It's just when we get to the tablets here, 60 milligrams, one tablet. We multiply out the top, it's still 1/2 times 60 times one tablet, that's still 30 tablets. However, on bottom, it's 1 times 1 times 60. We divide out 30 tablets divided by 60 is 1/2 a tablet. Which is more accurate to give to the patient? 2 tablets, yes. Even though they're scored, you can't be certain that when you split it, you get it exactly.
Rarely.
There's always some sort of concavity in the split. Although I have seen a couple of pill cutters that do a very good job of cutting. Kind of messy.
But the traditional person will like that they have in the kitchen and then
Or I'll
they
just snap it.
crumbly, yep.
Of course, the greatest thing about cutting with a knife in your kitchen is usually half of them shoots across the room and you never find it again until the dog ends up acting really weird.
Longer, yeah.
Okay, so I'm going to have you guys try some in your notes. You have a little bit longer calculation to them. So we've got an order for astrophene sulfate. GR 1/200th. Their supply, .4 milligrams per milliliter. Find for me how many milliliters need to be administered to the patient. let's see how you're doing with this. We start out with the order of 1/200th of a grain. So we can do it as 1/200th of a grain over 1. We could do it as 1 grain over 200, and I'll show you that in just a second. I'll show you how that works out the same. There's already a fraction in our ordered dose. We can just use that fraction instead of forcing it by putting it over 1. We have to get rid of grains. Now we need to know, what are we converting grains into here? Usually grains can either go to grams or milligrams. Here we want milligrams. The relationship, 1 grain is 60 milligrams. If I were going the other way, by the way, how many grains are in a gram? Does anybody remember? I won't make you look back. It's 15 grains in 1 gram. Remember, that's that rounded conversion. That only multiplies up to 900 milligrams in a gram. There's technically like 64 milligrams in a grain, and like 15.3 whatever. It just got really ugly, so they just rounded them. So anyway, that's going to cancel out our grains. Then we have the relationship. Milligrams, 0.4 milligrams per milliliter, so that's saying 0.4 milligrams is equivalent to 1 milliliter. That's really the key, by the way, is anytime you see a rate, that becomes an equivalency. 0.4 milligrams equals 1 milliliter. Milligrams cancel out, so we'll multiply. 1/200th times 60 times 1 milliliter, 60 200ths of a milliliter, over, on the bottom I have 0.4. Rather than reducing this by hand for you, I'm calculating this on the calculator. I'm going to calculate out that numerator first. 60 200ths is just 60 divided by 200. I'm going to hit equal. Then I'm going to divide that by 0.4. This is 0.75 milliliters. Let's try one more before we.
Yeah, that's what he's gonna show us now.
Okay.
Let's try one more before we move on to flow rates. Say we have an order for heparin, 50,000 units. Our supply, $10,000 units per milligram, 12 milligrams, and 5 milliliters. Give you a minute or so to try to work that one out before we go over it. Take a look and see how you're doing on this.
And then 5 and 12.
We're going to start out with the doctor's orders of 50,000 units over 1. And now we're going to get rid of units. 10,000 units in 1 milligram. Cancels out the units.
Gives you
Now we have milligrams. We're going to get rid of milligrams. Our next equivalency does that. 12 milligrams, 5 milliliters.
Which we rounded down to 2.
The milligrams cancel.
So that's on a tablet.
So on top, 50,000 times 1 times 5 milliliters is 250,000 milliliters. On bottom, 1 times 10,000 times 12, 120,000. If we divide that out, what do you get, like 2.083 milliliters?
Good job.
not bad.
I'm glad I asked you so I could go back and see.
Yeah.
I forgot the 12.
Okay, so before I move on to IV flow rates, I said I would go back and show you how to do this where we have a fractional dosage like that, 1/200th of a grain. We could write that, instead of doing the 1/200th of a grain over 1, we could have done 1 grain over 200. That's still 1/200th of a grain. And we could have converted with that. 1 grain is 60 milligrams. Canceled out the grains. And then we had, I gotta go back and find 0.4 milligrams in 1 milliliter. Comes canceled out. So what we would have had here is 1 times 60 times 1 milliliter is 60 milliliters. 200 times 1 times 0.4. 200 times 0.4 is 80. 60 divided by 80 is 0.75. So when the ordered dose already contains a fraction in it, we can use that fraction rather than having to manufacture one by putting it over 1. Go up here, put the 1/200th over 1. We got the same result, but it was really awkward multiplying through by that fraction and getting fractions within a fraction. Whichever way you prefer, or was easiest for you, fine by me. Okay, so for the last 10 minutes or so, let's talk about IV flow rates. All the dosages we've talked about so far have been one-shot dosages, single dose, all at once. But sometimes we want to administer things over time. So flow rates can be given in several different forms. One of them can be in milligrams per hour. If we have an order of 1,000 milligrams over 8 hours. Flow rate, the amount of medication over the time. Here is 2,000 milligrams over 8 hours. Two 2,000 divided by 8 hours. 250 milligrams per hour. That is the flow rate for that order. That's relatively simple, just dividing it out. But if you've gotten to know me at all, you know I don't keep things that easy. It's my job to make it worse. So let's say we are ordered to administer 400 milligrams over 20 minutes. You still want this flow rate in milligrams per hour. So we have 400 milligrams per 20 minutes. The milligrams we want to keep. We want milligrams on top. It's the minutes we want to get rid of. So since minutes are on bottom, we'll put them on top so they cancel out. And we're converting to hours. The hours on bottom, of course, the relationship is 1 hour is 60 minutes. Minutes cancel out. 400 times 60, 24,000 milligrams. 20 times 1 hour is 20 hours. Divide the 24,000 milligrams by 20 hours, that's 1,200 milligrams per hour. Since what we're putting into the patient is a fluid, it's usually simpler to measure it rather than milligrams per unit of time. Simpler to measure it in milliliters per unit of time. So we often will do that as milliliters per hour. So if we have an order to administer 4,000 milligrams, 8 hours. We look at the label on the bottle, it tells us our supply (25 milligrams and 4 milliliters). Get our flow rate in milliliters per hour. We have milligrams, 4,000 milligrams over 8 hours. We're going to have to convert both the milligrams. No, the hours are going to stay. We keep the hours, but we got to convert the milligrams. Got ahead of myself there. So milligrams are on top. We need to put them on bottom so they'll cancel. And our supply here gives us that equivalency. 25 milligrams is equivalent to 4 milliliters. 25 milligrams and 4 milliliters. Milligrams cancel out. Now again, we could do some cross-canceling with our fractions here if we wanted to, but since we have calculators, let's do it the safe way. 4,000 times 4 is 16,000 milliliters. 8 hours times 25 is 200 hours. 16,000 divided by 200 is, what is that, 80 milliliters per hour? That's a flow rate of 80 milliliters per hour. Sometimes we want our flow rate in, rather than milliliters per hour, we want it in milliliters per minute. So our order might be 5,000 milligrams, 4 hours. Look at the label, it tells us that supply is 125 milligrams 30 milliliters. So we start with 50 milligrams, 4 hours. That is the doctor's order. 5,000, sorry.
We said 50 and I was.
Sorry, it's 5,000 milligrams over 4 hours. Sorry about that. Little hamster's taken off for the weekend already, I think. Now, we need to get rid of milligrams. Milligrams have to become milliliters. So let's do that. Milligrams go on bottom. Our equivalency here says 125 milligrams is equivalent to 30 milliliters. So the milligrams are gone. We now have milliliters on top, which is what we want. However, we want to have minutes on bottom. We currently have hours. We need to cancel out those hours. Hours are on bottom, so I'm going to put them on top to cancel them out. And of course, 1 hour is 60 minutes. Now the hours cancel out. So now we have milliliters on top. That's what we want in our numerator. Minutes on bottom. That's what our denominator. Good for our units. Let's multiply them out. 5,000 times 30. 150,000 milliliters. 4 times 125 times 60. What's that, 30,000? Divide that out, that becomes 5 milliliters per, 5 milliliters per minute. Lori? Any questions there? The next step in this bring in something called a drop factor. A drop actually is a standard unit. However, it's a standard unit based on water. So for medications, they're similar in density to water, but they're not necessarily similar in viscosity. Viscosity means thickness, how easily they flow. So it's that flow, that viscosity that determines how many drops it takes to make a certain volume. So a drop factor for a fluid tells us how many drops to make 1 milliliter. Drop factors typically range between 8 to 20. The units used is drops per milliliter. That's a GTT. Sorry. I should separate them. So if we have a drop factor of 12 drops per milliliter, that's an equivalency. That's telling us 12 drops is equivalent to 1 milliliter. And that's going to be what we use as our conversion. That is where we will start next week. We have 2 more weeks of lecture on this class. This is a longer unit. The test is scheduled for November 8th for this unit here. Homework, a little less of it tonight. Page 162 through 163, 1 through 23, the odds. That's using the dosage calculation formula along with some of the other strategies. If the book says to use the dosage calculation formula and you prefer to use a different method, please feel free to. Or if it tries to tell you to use proportion and you prefer a different method. Obviously, I'm a fan of the dimensional analysis, but you don't have to use that method just to make me happy. Also, page 172 to 173, 1 through 9, the is more practice on dosages and constituting medications. So like I said, use whatever method works best for you when you're doing the dosages. Okay. That's it, just the two. Yeah, I know, not 5 or 6 pages this time. Don't get used to it. You guys have a great week. See you next week.